Welcome to the Agentic Workload Swarm Scheduler Showcase. As part of the AI RAN Alliance demos at Mobile World Congress 2026 in Barcelona, GlobalLogic, a Hitachi Group company, in partnership with Keysight Technologies, is excited to present our vision, solution, and deep enthusiasm toward shaping the future of telecom innovation. The over-the-top, or OTT problem, means customer service providers often serve only as a data pipe for hyperscale cloud providers, capturing a small share of the total revenue. Can this market position be fundamentally shifted? We envision a telecom network as a pervasive compute fabric of distributed data centers interconnected by the CSP's own transport channels, representing the desired state. GlobalLogic's solution uses AI RAN to transform the network edge, enabling radio access networks to natively host and accelerate AI-specific tasks with intelligent workload agents. The AI workload agent runs at UEs and G-Node Bs, performing the workload magic. This is the key intelligence element of the solution. The UE requests a GPU to process video streaming, reaching the first AI RAN-enabled G-Node B and its AI workload agent. The first AI workload agent responds, acknowledging that it lacks resources but stating a friend will help. Another AI workload agent at a different G-Node B cluster, which has a GPU, happily agrees to help. The GPU service is then provided directly by the resource-available GNB to the UE, fulfilling the request efficiently through the distributed network. Centralized orchestration uses an inventory database for scheduling AI workloads. Our decentralized approach, however, uses swarm intelligence. Each G-Node B cluster has its own AI agent acting as a peer. The Agentic Swarm Scheduler views the AI RAN network as a resource pool. AI workload agents communicate to spread workloads based on the context of the AI task and resource availability, like a swarm of insects searching for food. The Kubernetes architecture used as a baseline for integration into CSP networks. It incorporates the proposed Telco Controller Manager. This new component is key to enable Kubernetes intercluster communication in AI RAN. It contains the core AI agent logic, including the Swarm Scheduler. AI workload placement begins with the UE-hosted AI agent communicating with the G-Node B's AI agent via MCP protocol. The G-Node B AI agent uses the A2A server to exchange resource state awareness with other AI agents. The Swarm Scheduler applies a fitness function to determine the best workload placement. The blueprint shows how MCP clients, through MCP protocol, send requests. AI agents communicate resource state using a 2A protocol across the network to inform the Swarm Scheduler's fitness function. This flow allows the Swarm Scheduler to make an optimal, decentralized decision about where to deploy the AI workload based on network-wide resource awareness. GlobalLogic Lab implementation is a high-performance Golang application with a flexible architecture. The core intelligence layer features the Swarm Scheduler with a configurable algorithm selector for workload placement and workload optimization, including ant colony and particle swarm optimization. Model training in data centers is a well-known area for IT industry, while model training on the RAN infrastructure is a terra incognita for the telco industry. GlobalLogic partnered with Keysight to validate the Swarm Workload Scheduler's orchestration of machine learning task flow, including model training and inference, leveraging Keysight's KAI Data Center Builder for realistic traffic generation, and the Network Fabric Emulator for precise environmental modeling. Together, we aim to demonstrate how swarm intelligence orchestrates complex ML workflows across high-performance compute, allowing CSPs to transform underutilized edge resources into premium, AI-ready infrastructure. Now, we will proceed with a live demonstration of the Agentic Swarm Scheduler. The interface provides full visibility into the swarm logic. At the center is our network topology, flanked by the MCP and A2A protocol windows. Telemetry is tracked in the status monitor below, while the control plane at the top manages the entire environment. We can scale the swarm to 3, 8, or 16 clusters, each powered by its own AI agent. For this demonstration, we will deploy an 8-cluster configuration. As the system initializes, an MCP client requires GPU resources for inference. It requests a workload allocation from Cluster A. However, Cluster A lacks the immediate capacity to fulfill this demand. The local AI agent immediately initiates intercluster communication, querying the real-time resource states of all neighboring agents across the network. Once the telemetry is gathered, the agent on Cluster A utilizes the Swarm Scheduler to identify the optimal node. The decision is finalized. The workload is seamlessly placed, and the MCP client is notified of the successful allocation. Ready to take the next step? Scan the QR code to schedule a consultation with one of our experts. Thank you for watching.